people write in cursive? That's it? How many people here print? Oh my God. You really can't read my writing then. Okay. It's a choice. Both forms can be used to write, correct? Well, some people like to talk about chance in terms of the probability definition of chance, and some people like to talk about chance in terms of the odds definition of chance. So if we talk about chance, we already said that the probability of success, okay, or A, is going to be equal to the number of successful events. This is the successful event. It's the number of ways you can achieve the successful event divided by the total number of possible events under the constraints of the problem. Remember? Yes. Now, that number, where P of A is anywhere between 0 and 100%, or 0 and 1. Agreed? And we know it can't be bigger than that because the most NA can be is NS, and NS over NS is. But, and this is called probability. Probability. But you can also talk about chance using another language. Odds. Okay? And odds of your successful event A happening is a ratio. It's the same numerator as probability, the number of ways you can achieve success, but it's divided by the number of ways you can achieve failure. And do you remember complement means the opposite of the event? So do you remember A prime means the opposite of A? Okay. So if you define things in terms of event A and the opposite of A, what is the sum of NA plus the opposite of NA? NS, right?
Which is 1.
If you add all possible ways you can succeed plus all possible ways you can fail, you have the universal set of possibility. So another way you can write this is NA over NS minus NA. Okay? Are you guys with me so far?
Sure, I didn't get the last thing you said. If you subtract away.
So, if you have this box is the universal constraint of possibility given the nature of the question, and this bubble represents the number of ways you can succeed, well, everything inside the box and outside the bubble are the total number of ways that you can fail.
Yeah.
Clearly, the sum of successes and failures equals NS. So odds is written as the ratio of the number of successes to the number of failures. But keep in mind, the number, if you happen to know the universe of possibilities, then you can also just write it as the ratio of the number of successes to the total number of possibilities less successes. Because total number of possibilities less successes gives you failures, right? So odds doesn't have that constraint on it, right? Because what if your success to failure ratio can be greater than 1? Agreed? You know what I'm saying? Here, maybe it's nicer to write this like this. Instead of 100%, I'll call this 1. Can odds be greater than 1? Sure. You might be 3 times, there might be 4, let's say let's say NS is 4. And let's say 3 of those events are successes. So that would be 3 to 1. Agreed? That's greater than 1. So you don't have that constraint. So I could say, for example, if the probability of event A happening is 1 out of 4, then the odds of A happening, quite simply, are going to be 1 over 4 minus 1, which is 1 to 3. Agreed? This is total number of successes divided by total number of possible outcomes. Odds is going to be the ratio of successes to failure. Successes is 1, just like with the numerator of probability. And failure is going to be total number minus successes. 4 minus 1 is 3, right? So if you have something in probability and you want to turn it into odds, keep the numerator and make the denominator the difference between this and this. Got it?
Yeah.
Okay. Now, you could also see odds written in terms of probability. So you could also say that this is the same thing as the, well, let me just write it this way. Or divide numerator and denominator of right side by ns. If we divide the numerator and the denominator of the right-hand side of this equation by ns, is that allowable? Can you do that in an equation? If you have y is equal to x, let's say you have y is equal to a over b. If I divide the numerator by 3 on the right and the denominator by 3, you still get a over b, because the 3's cancel, right? Yeah. So I want you to go ahead and do this. So you'll have na over ns divided by ns. You're just dividing the top and bottom of the right side by ns. Actually, let's do it for, we can do it for this and we can do it for this. It doesn't really matter. And what you find is that you can also express things like this. Let me get out of the way. So you can also say that odds is equal to, you can define odds as the number of successes to the number of failures, or you can define it as the ratio, the probability ratio. Probability of success to probability of failures. Why? Because the ns from each denominator offsets. The ns is offset, right? And you can define it this way as too. Instead of just doing it as na is ns minus na, you can do it as pa over 1 minus p. Okay, agreed? You guys follow this so far? Now, this is a very, very important property, and we take advantage of that property. We use it at summation to 1 property for probabilities a lot, okay, to get solutions. So my advice to you, and you'll see this as we do questions, is when you're doing problems whereby you may be asked to calculate odds for something, and it's not a simple thing like this, like, oh, if the probability of event A is 1 over 4, what are the odds of event A? Oh, it's just going to be 1 divided by 4 less 1, which is 1 to 3. That's easy. But sometimes you'll be given a question which involves you, which requires you to give an answer in odds, and it's a multi-step question. The rule of thumb is you work in probability all the way through, and then at the last second, what do? Switch it to odds. So you do all of your big moves in probability land, probability universe, and you get your probability, it comes out to, let's say, 2 over 7, and then last you turn it to 2 over 5. To odds of 2 over 5. Does that make sense? Yep. Okay, so that's that. And now we should start doing some questions, I think. I'm going to get Kate to do some attendance. I need you to mark Ilya late. I need you to mark who else was late. Rohan and Naomi. You almost flew under the radar. You shouldn't put up your hand. Yes, there was a question.
So can we say that odds of A is between 0 and ns?
Let's think about that. Odds, well, odds definitely, I would agree with you, is got to be.
Do you agree with me?
Yeah, I'm sure it's shocking, isn't it? Odds can't be negative, right? Because you're talking about numbers of ways. It's a count. It's a positive count. No. So positive over positive is positive. And you're saying maximum is going to be ns?
Maximum is going to be ns, but it can't be equal to ns.
Okay, so you're saying it's this. Let's think about that. All right. Okay, so he's saying that the numerator, no, it could be infinity, couldn't it be? Because couldn't you have 0 chance of failure?
Yeah, if you have.
Yeah, but
Okay.
So then you'd have ns over,
0.
you could have ns over 0.
So it's 0 to.
So yeah, I think it's infinity. So I don't agree with you.
Wasn't
There.
that undefined?
Oh, did you say undefined? I thought you said between 0 and ns.
But undefined is there's no answer for it, so it doesn't count in this range.
What?
You mean
Don't you take MHF?
if NA prime is 0, then it's undefined.
Here.
That means there's no
Here.
answer for it.
Somebody tell me, what's the range of this graph?
greater than 0.
Yeah, or could I also say that it's 0 to positive infinity? Am I allowed to do that too?
Yeah.
Yeah. No, but you didn't say this. You said NS.
Yeah. You're right.
So you...
Surprisingly, I'm right, huh? Yeah, that's another line, but that's good. Okay, so that would be the boundary for odds if we were to look at that. But it's still a good, worthwhile thing to do. Okay, let's get moving. Let's start doing a blitz of questions. Yeah, there's some more stuff I have to teach you about there's more stuff, more theory about dependent probability and so on and so forth. But let's start doing some questions.
Sure.
Or should I just teach you all the theory first? Maybe I should teach you the theory first. Just finish with it. And then we can do everything.
Can you like show the question at this stage?
Okay, you just want to do a question at this stage?
Yeah.
Okay, why don't you guys pick a couple of questions from 6.1, 6.2. Let's do those, and then we'll move on and we'll just finish the theory. The reason why I generally like to teach all of the theory in all of the courses that I teach for a unit first is because if you think about it, when you do a test, right? On a test, after a question, is there a little subscript that says this question came from section 6.2 or this question came from 6.1?
But when you read it, you can like immediately know it.
That's your job to know it, to figure that out. But my point is that I like to give you all, and on an exam especially, everything is mixed. So I want you to have all of the theory, and I want you to make choices based on.
Sure, you are the boss. You decide.
Well, I want you to be the boss and you to decide. And for that, you should have all the theory. That's the same reason why I taught you combinations and permutations at the same time. Remember?
Yeah.
Because if I just taught you permutations first, then we would do all of the questions with permutations. You know what to expect, right? Then I teach you combinations. You're like, oh, this is going to be combinations. Then it comes to a test, and you're like, oh, which one do I use? I want you to spend as much time at the beginning of a unit having to figure out which one to use. Because when it comes to a test or an exam, guess what? You're going to have to figure out which one to use. Yeah.
But the thing is,
no, I can't do this.
Get lost here right now.
No,
you keep
somebody do something with it.
We gotta
okay.
see questions.
Questions. Which ones are we doing?
Does anybody have a tape?
Duct tape.
Duct tape. I don't have any. Any ideas? Any questions?
I have a
page. What?
Like, do you want to type him with the roll?
I don't think we can do that, and this thing is being taped. So whatever you do, we're going to be in trouble.
We can use that cable if you want.
We're going to have to shut off the camera, and then we can do anything you want.
I can use this as evidence. You're talking about the client.
Yeah.
We can put him the toy over here and like in his mouth.
You don't know what we're talking about. We could be talking about piece of paper right now.
Okay,
come on, think of something. I mean, I can think of questions, but right now I'm tired, so I'd rather you grab questions from the book.
Sir, can I ask a question?
Wait. Okay, you want to do this right now? Fine. Suppose that the Toronto Blue Jays face the New York Yankees in the division final and the president. Okay, fine. Tree diagram. Okay, we're not going to do the tree diagram. Okay, what page is it?
313.
Page 3.
13.
Okay. Can you read the question, please? What question number?
10.
10? Okay. Those of you that have books, share with other folks. We'll try it together. Go. Read.
Suppose that the Toronto Blue Jays face the New York Yankees in the division final. In the best of 5 series, the winner is the
Wait, best of 5. I have to explain what that means. Okay, guys, this is important because those of you that follow sports know what this is, and those of you that don't have to understand. When you talk about a best of series in sports, okay? Typically, when you talk a best of series, it's an odd number of games. The series is listed as an odd number of games. And the number of games isn't necessarily the number of games played. It's the maximum number of games that can be played. In other words, if you talk about a best of 5 series, you're talking about the first team to win a majority of 5. What is the majority of 5? 3. The minimum majority of 5, 3. So the moment a team wins 3 games, there's no need to play anymore. Because let's say Yanjun and I are in the series, and let's say Yanjun wins games 1, 2, and 3. what if the objective is to win a majority of games in the series? What is the point of playing games 4 and 5? The best I could do is win games 4 and 5, in which case Yanjun would still win the series 3-2, right? So if you're talking about a best of 7 series, the first team to win 4 is the winner. In a best of 9, if you had it in a best of 3, the first team to win 2. Now, I do think there's a question in the book that has a best of series which is an even number of games, which to me seems silly. But I guess in that case, if you have a best of and it's even, like let's say you have a best of 6 series, then you still got to win. You got to win 4, right? Okay, does that make sense? So in a best of series, you do not. That's the maximum number of games played. The series does not necessarily go the max. The series only goes the max if the teams have split 5 minus the total of 5 minus 1 games, right? So if the first 4 games somehow have gone 2-2, it doesn't mean that it had to be she wins 2, I win 2. It could have been I won 1, she won 1, she won 1, I won 1, or I won 1, she won 1, I won 1, she won 1. But if after 4 games we are tied 2 wins apiece, then you have to play the 5th and deciding game. If it's a best of 7, it would be 3 apiece, and then we would have to play the 7th and deciding game. Is that clear? So the range of possibility in terms of number of games played in this case would be a minimum of how many games played? 3, and a maximum of, in a best of 7 it would be a minimum of 4 and a maximum of 7. Right. Okay. Now, so it's a best of 5, and it's Toronto versus New York. Okay, go on.
It's a game. The winner is the first team to win 3 games. The games are played in Toronto and in New York, with Toronto hosting the first, second, and if needed, 5th game.
Okay, so wait, game number 1, game number 2. So in Toronto, games number 3. Game number 4.
No, only with 3 and 4.
Hang on. Game number 5. So this goes in New York. In New York. And then in Toronto. These games are if necessary. Do you guys understand why those games are only if necessary? Because Toronto or New York, it could go Toronto wins, or New York, in which case there's no need to play those. So these are not necessarily going to happen. Okay, go on.
The consensus among experts is that Toronto has a 65% chance of winning at home. And
okay, hang on. The probability of Toronto winning at home is 65%.
Sure. And away is 40.
Well, obviously the probability. They said the probability of Toronto winning away is 40.
Yeah.
For a second, I was going to say those numbers had to add to 100, but they don't, do they? If the probability of Toronto winning at home is 65%, what is the probability of New York
Winning away.
35.
winning away? Yes, good, 35. You guys understand this will mean Toronto winning at home?
Yeah.
And this will be Toronto winning away in New York? Maybe it's better if I do this. Instead of writing H, why don't I do this? T and T and T in. That's better, I think. Right? Probability of Toronto winning in Toronto is 65%. Probability of Toronto winning in New York is 40%. Yes?
I think it should be game 4 and game 5 if necessary, because you first. Yeah, but the bracket is including the.
No, it's not.
It's not. Don't argue with necessary.
You can argue with me all you want. Milad, when has that ever stopped you? Okay, what's next?
What is the chance of Toronto winning in 3 straight games?
Chance. So if they say chance and they don't force you to use probability or odds, I would usually just go with probability. So what is the probability that you have Toronto? So basically, if Toronto, it says Toronto winning in 3 straight. So that means it's going to be a Toronto and a Toronto, followed by a Toronto and a Toronto, followed by a
New York.
Toronto and New York. I guess you can do it like that. That make sense?
Yeah.
It said, what's the probability that they win in 3 straight games? Well, where's the first game played in? So obviously that means you go Toronto, 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 right? But the first game is in Toronto, so that'd be probability of Toronto winning at home, Toronto winning at home, Toronto winning in New York. Yes, Milad.
It says 3 straight games. It doesn't say it starts from the beginning.
Oh, yeah, he's right. He's right.
Surprising.
Nice, Milad. It doesn't, yeah, it says 3 straight. It didn't say the first 3. Sorry, usually when I hear 3 straight, I usually think,
First 3.
is that not what that means?
Yeah, the first 3 games they
No,
lose.
I don't think,
Oh,
I think he's, I'm not sure. Does 3 straight mean you win the first 3 or just means that
No,
you...
3 straight. 3.
So you could lose the first and win the next 3?
Yes.
Okay, so then,
Or you could lose the first 2.
okay, so we have a lot of possibilities then, right?
3 plus
Which makes it nicer. So probability, Toronto wins 3 games in a row. Right, Milad? Better?
Yeah.
Good. Nice. Now, that makes the question better too, right? More interesting. Now, we get back, do you remember that whole situation before with, when I taught you combinatorics, the idea of and or, multiply and add, do you remember? Sorry, do you guys remember in under what circumstances you add and under what circumstances you multiply?
Yeah.
Yeah, what is it? What are they? Yes.
So if you have different stages in a situation, you multiply it, and then if you have different different stages which is mutually exclusive, then
Nice.
then you add it together.
Nice. Events that can happen simultaneously involve multiplication, whereas mutually exclusive events require addition. So I could ask you, in how many ways can you roll a 6 and flip a coin and get heads? Well, can those 2 things happen at the same time? Yes. How many ways can you roll a 6 with 1 die, 1 way? And actually, let's say, yeah, whatever, 1 way. And then heads is 1. So you would say 1 times 1, okay? But if I asked you how many ways you could roll a 6 or a 2, there's 1 way you can roll a 6, there's 1 way you can roll a 2, but you cannot roll a 6 and a 2 with the same die at the same time. So you would say 1 plus 1. Either you roll the 6 or you roll the 2, in which case you get a solution of 2. So in this particular case, we're going to have to examine different paths involving Toronto winning 3 games in a row. Toronto could win the first 3, right? The second 3, and so on and so forth. Can Toronto win the first 3? Can Toronto win the series by winning the first 3 games in a row and losing the first and winning the next 3 in a row?
Yeah.
Can Toronto win the series by winning the first 3 games in a row and then also
You don't
losing the first game and winning the next 3 in a row? No. It's or, right? Can't have that happen at the same time. So what we're going to have to do is figure out all of the different pathways, all of the different unique pathways in which Toronto can win 3 games in a row, and we're going to have to add those pathways. Agreed?
So that's why I asked for a tree diagram.
You can use a tree diagram in any case, but you can use a tree diagram in any case. But yeah. Now, I'm realizing something else. Because as we go through this, I'm going to have to multiply probabilities. And I haven't really shown you the justification for multiplying probabilities yet, have I? I haven't proven to you, let's say the probability of event A is 1 out of 2. And the probability of event B is 1 out of 2. And they are mutually exclusive events. I have to prove to you that the overall probability of both of them happening can be arrived at by going probability of event A times probability of event B. 1 over 2 times 1 over 2, right? I have to prove that to you. You know that it works for number of events, and I haven't shown it to you for probability. So we should be able to prove it quite easily, but unfortunately we have to do an aside. I can't just do that. I haven't shown you that. So we're going to do an aside. Prove that for events that can coexist, all events occurring equals P event 1 times probability of event 2 times probability of event 3, etc. You guys know what I'm saying? I have to prove to you that the probability of multiple events taking place can be of events that can simultaneously exist or coexist is simply the multiplication of the probability of the individual events. So let's see if we can do that. I'm always bad at this proof. So let's see if I can do it without screwing it up. If I do, we can always refer to the textbook. So, I don't want to erase the board, whatever. Just keep working over here.
So we can go from the side.
Yeah, but maybe I can do it like this. And maybe I can do something like this. Maybe I can swing around there and come around there. Okay, so our left side is P E1 union with P2 union with P, no, it's and, right? Does that make sense? So you're having all of these events happen at the same time, right? So, I don't know, I'm just thinking about it in different ways. Like, I don't know where this proof is going to go. But let's say you were dealing with 3 objects. I don't know, I'm using a picture now. Do you agree that this area here would correspond, let's say this is N E1, let's say this is N E2, let's say this is N E3. Do you agree that this little area over here is going to be N E1 intersect E2 intersect E3? Does that make sense?
Yeah, makes sense.
I'm glad, because I have no idea where I'm going with this afterwards. So that's the same thing as N E1. I don't know what I'm going to do.
So you are writing the same thing as the other part?
What?
Just the
And that is, so that's going to be that divided by, this thing is NS, right?
Oh, yes.
Oh boy. Now, if we can break this thing up into NE this over that, times NE this over that, times NE this over that, then we did it, right? How do we do that? How can we, do you know what I'm saying? If I can somehow show that now I can write, this is the same thing as NE1 over NS times NE2 over NS, and so on and so forth. Well, what's NE1 over NS? That's PE1, and so on and so forth. So can we do that? How many of you guys see what I'm saying?
Yeah.
Okay, am I allowed to do that though?
No.
Why no? Well, it has to be yes, otherwise I can't do this. Scheiße.
You can't.
What do you mean I can? Why not? Should I go to the right side then?
Let him think about for 2 minutes.
Yeah, maybe.
Oh, but wait a minute. If we go to
Anyone over NS?
I know, but it's like, I'm gonna be stuck.
Yeah, you don't know how to get from E1.
I'm gonna be stuck, right?
NS.
Or maybe I'm not. We'll see. I don't know. Let's just go with it and see where it goes.
Multiply by
This is actually ridiculous, but. And that, how many NS's do we have?
n.
That's NS to the N, right?
Yeah, to the power of n.
So we have
NS to the power of n.
NE1, NE2, NE3, NEn over NS to the power of.
N.
No, not N.
N.
No. N means number of.
But you start from 1 to N. You say E1 to EN. So N.
Oh shoot! Yeah, we shouldn't use an N, right? Because look, let's use a different letter here.
N.
Oh yeah.
M. Okay, fine.
Yes, why?
M. We're gonna make this an M. Where else do I have to make it an M? Here. 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 And then here. I don't know where this is going. I don't know where this is going. Okay. Let's go back over here. I have a feeling there's a lot easier way to do this, but. Okay, now I need to think. You guys think and I'll think. And let's see, hopefully one of the two of us. Two of us meaning me and you, the collective you, will come up with an answer. Let's pause it, Yunjin. I gotta think. Anybody have anything? First thing, okay, so wait. The first thing I'm thinking of is, in this case, I don't think I can use just NS's, because this is the probability of event, this is the number of ways event 1 can happen divided by the universal number of ways event 1 can turn out. So actually, isn't this NS1?
Why?
And isn't this NS2, 3,
They're all in
4?
the same universe.
In which case, this comes out for now, actually.
No, it's in the same universe.
No!
I agree with
I
you.
disagree. No, I disagree with what I wrote. I think that makes sense, because think about it. Let's say event 1 means rolling 6. What is NS1? How many? 6, right? You can roll 1, 2, 3, 4, 5, or 6, right? And if event 1 is rolling a 3, then the probability of event 1 is 1 out of 6, right? Let's say event 2 is flipping a coin. How many, what is NS? 2, and what's the probability of getting heads? 1 out of 2. So these actually are not the same S's, are they?
No, but that doesn't solve it.
I didn't say it did, but it changes the right
The
side.
last one is NSM.
NSM, yes.
MSM.
At the very least, though, that's important, right? Because what I wrote before is not true. Okay, maybe this will help us. Milad is laughing at me. I think we're good, though. I think we're going to be good.
Gonna to be
Okay, I'm nibbling away at this thing. I really should do this in one move, but I don't see it yet, so. Now, I could always cheat and use the book, but where would be the fun? NS. NS is the total number of ways all of the events can happen. And the events can coexist. So guess what NS is equal to? NS1 times NS2 times NS3 times ... NSM. Agreed?
No.
What do you mean no?
I don't understand.
NS is the total number of ways the macro experiment can come out, right? The macro experiment. So let's say the micro experiments are rolling a die and flipping a coin and
Oh, I understand.
hitting a basket and so on and so forth, right? Those are the micros. NS is the macro universe. This is macro.
Does it equal to S1 plus S2 plus S3 plus S3?
No, it can't be plus. It's not. Why is it not? You tell me why it's not plus. Why is it multiplied? Watch me be wrong. Why is it multiplication?
Because it's mutually exclusive.
No, it's not mutually exclusive. We said that we're doing this for events that can coexist.
Oh.
So in other words, if you do a tree diagram, let's say there are 6 ways.
I know.
Let's say there are 6 ways of rolling a die, right? And let's say there are 2 ways you can flip a coin. For each of those 6 branches, you get 2 branches, heads or tails, heads or tails, heads or tails, heads or tails. It's not an either or. So it's a multiply. Janice, do you agree with that? How many of you guys agree with that so far? It's not an add, it's a multiply. So now we got this. We're very close here, people. We're very close. Hey, check that out. What is the numerator here?
And
It's this is this. This is the probability that all, look at the numerator, that is the probability that all of the successes for each event happen. Right? This is the number of ways event 1 can happen, and the number of ways event 2 can happen, and the number of 3. So this whole numerator corresponds to the number of ways successfully, right? That is this. That's the same thing. That's it.
Left side equals right side.
That doesn't look right. That doesn't look right. That looks right. Help me out here. Help me out here.
EN.
Take
That-
off the N after the E3.
These aren't ends. These are actually
Yeah,
intersections.
that's what I mean, the intersection.
E1, E2, E3, then intersect with the next one, then intersect with
And E.
the last one.
There's no
And
N.
EM.
There's no N.
Oh no, there's no end.
Why is this?
And guess what I need here?
Intersection.
Yeah. And that's going to be NS1, NS2, NS3, NSM. Now, I don't believe the book will do it like that. I think it'll probably, yes, Milan. What do you want, Milan?
I don't understand why NS equals to NS1 multiplied by NS2.
Okay.
Yeah, me too.
Okay. Let's, S is going to be,
This one I understand.
S is going to be the universe of possible. Okay.
Basically what it
Listen,
is-
there's going to be a macro event. There's going to be a macro event.
What's a macro event?
Meaning that this macro event is going to be based on micro events, multiple micro events. Micro event 1, micro event 2, and so on and so forth. All the way to micro event M. Let's say micro event 1 involves rolling a die and looking at the result. How many ways can micro event 1 happen? 6 ways. 1, 2, 3, 4, 5, 6. Let's say micro event 2 involves flipping a coin and reading the result. How many ways can that happen? Now, notice, I'm doing this such that these can coexist, meaning that they're not mutually exclusive events. Notice, that's why you get multiplication here, right? You get 6 times 2. So far there are 12 possibilities, right? Now, keep going. Let's say the last event involves, help me out here, guys.
Picking on a camera.
Drawing a red card from a standard deck. That's also 1 out of 2, right? Because there are 26 red cards and 52 cards. So then at the end, you'd also get a branch of 2. This tree represents the total number of ways
You can possibly. You get all the possibilities.
the macro event. So the macro event corresponds to the macro event corresponds to the total, so NS. So N of macro event. So macro event is going to be event S. And N of macro event, which is going to equal NS, is going to be the total number of branches you have on that tree. It's the total number of ways all the events can turn out. And that is going to be equal to, this guy here is going to be NS1, right? And this guy here, no, this was for the whatever, the die. This one's going to be for the coin, NS2. You have a whole bunch in between. And lastly, this one was for the red card. This will be NSM. So the overall outcomes for the macro event is the multiplication of all of those. Agreed? Yes. It's NS1, NS2, dot, 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 NSM.
You get it now? Oh.
I get that.
Good.
Another question.
Yeah, and what was the other? There was another thing you were asking. Okay, so that's good.
Okay, yeah. I got it the moment
Wait,
I asked.
Ken,
Okay.
you got it the moment you asked. So then why did you ask?
No, I asked and I realized why, and then Ken had the same problem starting.
Okay, Ken, what's your question?
My question is, how can you get the numerator from the second step? I mean the right side. How can you? I mean the numerator. So the third step.
This
From
to this.
second. Yeah.
Yeah, I have the same question.
Yeah. So what does this mean? So any 1, any 2, any 3, any m. That corresponds to the total number of ways. The multiplication of all this corresponds to the total number of macro successes. Now, each of the internal events can coexist.
Oh.
So that means the total number of micro success 1 times the total number of micro ways you can have, times the total number of micro success 2, times the total number of micro success 3, and so on and so forth.
So it's that part.
Yes. It's actually this little part in there. Does that make sense? So this whole big song and dance, now that we've done this whole big mess, we can actually use a very simple principle, which is to say that if you know probabilities of events that can coexist, and you want to find out the probability of both of the events, or all 3 of the events, and so on and so forth happening, you can just multiply the probabilities. Okay, and that's going to be a very, very important principle for us to take advantage of. Now, we don't have much time, but let's see if we can now go back to this thing. Okay, so probability of Toronto winning 3 games in a row. So one possibility is, I don't know if you might want to move the camera, Yanjun, after you get that, so we can get here. Probability of Toronto winning 3 games in a row, it can happen right here. We can have a Toronto win, so we can have G1, G2, G3, right? What's the other way it could happen?
G2, G3.
G2, G3, G4.
G3, G4, and G5.
G3, G4, G5. And that's it, because you can't go further, right?
We just add those.
These, notice, these are not micro, but you cannot multiply these probabilities.
Because they can happen at the same time.
This guy gets it. He gets it. He gets it. It cannot happen at the same time. So, but in order to get the answer for each of these, you can now treat each of these as a macro, right? You can treat this as a macro with its internal micros, this is a macro with its internal micros, and this is a macro with its internal micros. Agreed? I think, yes. Now what the hell am I going to do? I'm going to erase over here. So, let's talk about this guy. This one here. Toronto wins game 1, they win game 2, they win game 3. So let's just do this part.
70%.
So what's the problem? Well, for Toronto wins game 1, sorry, it's just I'm doing it because for myself actually. The first game is in Toronto.
65.
65. Nice. 65.
65.
The next game is in Toronto, 65.
And then
So 0.65 squared, right?
And then 40.
And then they got to win in New York, 40. Nice. So So that's that. Now, we're going to add to that this guy right here. Now, be careful. And actually, this isn't good. This is misleading. Because the number is going to be too high. What do I have to put in front here? Well, this means Toronto wins game 2, 3, 4. But this doesn't say whether Toronto, what has to happen in game 1? Toronto has to lose. Is it a guarantee that Toronto will lose in game 1?
Yeah.
No, so if you don't put that in, your probability will be too high. So we have to make Toronto lose game 1. So game 1, Toronto's got to lose. If Toronto has a 65, the first game is in Toronto, 65% chance of winning in Toronto, 35% chance of losing game 1. Now, they got to win game 2, and it's in Toronto. 65.
40.
They got to win game 3 in New York. 40. And then
65.
they've got to win, what are we at? Game 4?
New York.
New York. It's the same thing again, right? Agreed?
Yep.
Notice, this is a 3-game series, and that's why you have 1, 2, 3 object micro events, and this one is a 4-game series, and that's why you have a total of 1, 2, 3, 4 micro events. Am I allowed to multiply these events? Can Toronto win game 1 in Toronto and win game 2 in Toronto? Yes. So you can employ this, right? You got one more left. You got one more left.
35, 35,
You guys are too fast for me. Toronto's got to lose and lose.
35, and then 40, 40. I mean 40, 40, 65.
So this is a win, right? And this one was a lose, W.
This is a lose, lose, win, win, win.
It's got to go lose, lose, win. So
So it's 35,
35, yeah,
and then 35
which is 35 squared. Those are the 2 losses at home.
and then 40 squared,
Yeah.
and then 65.
And then lastly, wait. Yeah, Toronto wins again at home, right? Which is 65.
So we actually have 2 more chances, like ways. Like, for
You're scaring
example,
me.
Toronto wins the first game, the 4th, and the 5th.
No.
No, but remember the original question was 3 in a row.
Yeah,
3
that's
in a
for
row.
the next week.
So now what you got to do, so right here, this is a 5-game series. So now take.
Just multiply them.
No. What do you mean multiply?
No, like-
Yeah, but yeah, you multiply these, but you add, right?
Yeah.
So
Why are you laughing?
I'm just laughing because there's no room. So you figure out this, you do this, plus this, plus this. And what does that give you?
So it's more number. Right?
First one is 16.9. Oh, you want total?
Can't be 16.9, it's got to be less than 1. All you need is a percent.
Yeah.
Yeah, just give us a total. You can give it to us as a percentage or as a decimal. Are you guys following this? We did a lot today. This is a lot.
Is it?
Yeah. How many of you guys think this is a lot?
Yeah, I think so.
Really? Good. This is a lot.
Because I don't know why the textbook put the question at this stage and then doesn't include.
Maybe because they want you to draw a tree diagram first. So if you draw a tree diagram, you don't need to know, because we're not doing it with a tree, right? Isn't part A say do with a tree?
Point,
Yeah.
point
Part A
to
and
one.
C.
So we do. So what's the final answer?
21%.
Clean?
22%.
21.8.
22%.
21.8.
22%.
They're both the same, guys. You're both saying the same number. 21.8 is 22. Okay.
That's accurate.
Okay. Did anybody else get that? Because I don't. Is anybody else willing to sign off on that?
Let me check.
Oh, yeah.
Check the back,
What?
just so we have the percentage right at least.
Mira, do it. I know you
What do they have?
flip the paper. please.
Hang on. They have 17%.
What?
Plus.
Crunch again.
Should be 21.
Crunch again.
Should be 21.
Crunch again. Then that means either you calculated wrong with the calculator or we made a mistake.
We made a
book only did
Yeah,
Ah!
yeah, because the book did.
So the book only did.
Yeah, first one, which is
This one?
70%, yeah, 70%.
Okay, so the book's answer is this.
16.9.
Yeah, because in sports, typically when you hear, what was it? Sweep?
straight.
3 straight
Be
wins.
straight. Usually that's what they mean, but you know what? You're right. You're right. Really, they should have said sweep the series. When you say sweep the series, you mean that the other team doesn't win anything. So I think Milad's answer is more correct, given what they wrote. So the book is wrong. This is right. And, yeah. You understand? Put the desk back.